All right. Now let's talk about the other leg of the long-term carbon cycle. And this is the one where we are at fault. The organic leg of the carbon cycle. So let's talk about it. So it all starts here on the surface of the earth with plants, trees, animals, life. Well, I have bad news for you. So all of this life happens because of photosynthesis. If there was no photosynthesis, there would be no life. And so photosynthesis removes carbon dioxide from the atmosphere and then gives it to all of us. It feeds us carbon dioxide. It feeds plants carbon. So carbon is being removed from our atmosphere via photosynthesis. Now, a lot of this carbon is being released into the atmosphere via short-term processes such as bacterial decomposition, respiration, and other processes. But a good chunk of it actually stays put in living things. But unfortunately, those living things eventually die. A lot of that carbon dioxide that was absorbed by those living things is eventually put back into the atmosphere, but not all of it. There's not all of it. Some of it escapes oxidation and gets buried beneath the surface of the earth. This process is regularly happening all the time. This process is happening all the time. It's happening right now as we speak. Things are dying, they're decomposing. Some of the stuff left behind, however, still has carbon in it and gets buried and escapes oxidation. Well, what happens next is more things die. Some of their carbon gets buried, and then more things die on top of them. Some of their carbon gets buried, and then more things die on top of them. Some of their carbon gets buried, and eventually all of this carbon is weighing heavily on itself, and therefore it's compressing. And as it compresses, it undergoes a phase change. It actually changes from dead plants to basically sludge. And it actually undergoes a process of compression that actually turns it into coal, oil, and other fossil fuels. Additionally, some of the oxidation that happens or some of the decomposition that happens also results in some methane being stored beneath the surface of the earth as well. We're going to talk more about that methane in a little bit. Right now, we're just going to focus on carbon dioxide. If left untouched, this pool of dead organic material would take millions of years to rise back up to the surface and take millions of years to return to the atmosphere. And then we came along. We dug this stuff up. We found out that it burns really, really, really well. But by burning it really, really well, it released all of that carbon dioxide that would have taken millions of years to release, and it happened instantly. So what we as humans have done is we have taken a long-term process and we've made it instant. And so the rest of the natural processes can't keep up with that. That is why the burning of fossil fuels has sped up or has increased the amount of carbon dioxide in our atmosphere, because we have taken what was a slow process and we've made it almost instant. So here's this process in just a little bit more detail. So you have a tree. A tree's carbon-based. That tree removes carbon dioxide from the atmosphere and then releases oxygen and makes sugars via photosynthesis. But eventually the tree dies. Eventually the tree dies. Well, as the tree dies, that carbon, most of it gets decayed and removed and put back into the atmosphere. but some of it doesn't. And instead, that remaining carbon ends up getting absorbed into the land. Then the next year, more trees die and they get buried. And then the next year, more trees die and then they get buried. And it's not a whole lot, but over millions of years, it adds up. It adds up. So now we have this big pool of buried, dead, organic carbon. Basically just a giant sludge pool. And this giant sludge pool would eventually make its way back up to the surface of the earth, usually by erosion. It may also be exposed by upwelling or plate tectonics. There's all kinds of things that could push it back up to the surface. But a lot of it would be exposed by erosion. When it's exposed by erosion, it will then oxidize into carbon dioxide. Here's the thing though, if I took a lump of coal right now and I placed it on my desk and I just let it sit there, it's not gonna oxidize instantly. It's not gonna oxidize in a week or in a month or even in a year. It's gonna take a really, really, really long time for there to be an appreciable amount of oxygen or an appreciable amount of oxidation. However, if I put a flame to that thing, put a flame to that lump of coal, it's going to happen instantly. So once again, erosion eventually exposes this carbon. The carbon then oxidizes back into the atmosphere as carbon dioxide. But because this process is so slow, this release of carbon dioxide is manageable because other processes are offsetting it. Other slow processes are offsetting it. But by us burning it, we have made it too fast. By us burning it, we've made it too fast. And that is how we are screwing up the carbon cycle. So I'm going to talk a little bit more about that in the next few videos.